He leads Move Artificial Intelligence. This is a startup that is developing an artificial intelligence framework, transformation, human-operated mobile, but I can assure you he's a perfect human being, one of the best one in the world. Limo Schweitzer, please. And one of the moderators had to fly to Hong Kong, so we will be with us online. This is David Hansen. So, Limo, take it from here. Thank you.
Hi, good afternoon. So as you know, the robots are taking over, and in about 10 years, it's estimated by several prestigious studies that 50% of what we call work today, or tasks within what we do today, will be replaced by automation. And most of what you think is your job stability is going to disappear within the next 5 to 10 years. And it's a topic of much debate. And today we're going to look a little bit into the details of different aspects of robotic and drones. We've got some great panelists, specialists in very different areas of this subject matter. And I'd like to start by introducing David Hansen, who's joining us from Hong Kong. He will be on Skype later. We will show a little video of Hansen Robotics. And you've probably seen their viral videos of Sophia the robot. Let's... Can you... Okay.
It's important for me to be like a human, but my goal isn't to become a human or to replace anyone.
Okay, our next panelist is Gabriel Chachot, who is the CEO of Sky Sapiens, and we will. They make tethered military drones. We'll first see an introduction video, and then we'll hear a bit from Gabi.
Okay, thank you for you being here. It is my pleasure. Sky Sapiens is a very interesting company because we try to solve actually two problems, major problems in the drone industry. One is the energy. You know, a drone today can stay airborne for 20 minutes, 30 minutes, 40 minutes, hardly more than this. So we try to solve this problem by using a cable with energy and with fiber optics. Our drone can stay in the air weeks. And for doing this, it has to be able to stand very strong winds, rain, harsh environment, minus 20 degrees, plus 50 degrees, snow, whatever. Because you want it to be airborne, not only when the day is like today, but also, you know, when we have some difficulties. The second problem that associates with being able to stay airborne for a very long time is autonomy. And you know, when you say autonomy, you can start with 1 and ends with 100, and this is not the same. So we strive that our system will be able to be autonomous at the highest level of keeping the machine airborne at all times with no human in around, and also to do the mission by itself. So I guess we're not 100, but I do hope that we're around, I would say 85 to 90% of autonomy level. The rest, later.
Okay, our next panelist is David Keller, who is the managing partner in Prime2. It's a boutique product design company. Let's see a little bit about their portfolio.
So thanks for having me. We're Prime. Basically, we design technology, and today we try to provide companies with business design services from a point of view that understands the value of good design to every business. I think that's it.
Thank you. And just an introduction about myself. So I'm Limor Schweitzer, and I run a company called Move AI, which recently had a round of finance, and we are developing an operating system for autonomous robots, and basically trying to separate between the hardware and the software in the same way that previously was done by Android, by Microsoft. So quite an ambitious thing we're trying to do, democratizing mobile robots. So let's see if we can get now David. All right, so we'd like to start. We'd like to start the panel discussion with consumer robotics. So when we think of consumer robotics effectively today, there are a couple of products that come to mind. One is
hello.
Oh, there he is. Okay. So when we think of consumer robotics, there's iRobot that we can think of, vacuum cleaners, and there are lawn mowers, but there's not really many robots, many consumer level products that we can think of. The question to the panelists is, what do you think is the future of consumer robotics? So let's start with David Hansen. Can you hear me?
Hello, I can hear you.
Okay. So what do you think is the future of consumer robotics?
Diversity. Many different kinds of consumer robots. Smart speakers, to improved household robots, to anthropomorphic robots, like robots we make. From Sophia here, who is happy to see you, to our Professor Einstein, consumer robot characters, such as what you can see here. These are robots that cost only about $150. They're small walking robots, and they're real robots. The camera in the chest, microphones that are an array that directs the robot to the person's case. And we have many other kinds of small robots. Small Sophia, we're not the only one developing anthropomorphic robots for consumer robots. The such robots is to communicate with people in a more natural way. Voice interfaces communicating with people using natural and artificial intelligence that can research answers. But humans are also visual people. We communicate with our facial expressions. So I think anthropomorphic would be one area of consumer robot.
Okay, David. Let's hear other panelists. So what do you think about consumer robotics? You've had a lot of experience in product design. Where are things going?
I think that today the main issue maybe with consumer robotics is the question, what's the real value we get from them? Most of us have some kind of robotic cleaners, Roombas, maybe robotic lawnmowers, but it's still, I think, quite early to really understand what real value consumer robotics can provide us, because products such as Jibo or Kuri fail to do that, because it's cute, it's nice, but it's not really valuable. And I think that verticals that might be relevant for that is maybe telemedicine, or maybe areas in which we actually can gain real and true value that will be also provided with reasonable cost which is also quite an issue because none of us will be paying $800 for a robot that moves his head nicely. We need to have something tangible and valuable.
Okay. Gabby, this is one for you. So with drones, we've seen in the past few years over $2 billion of investments in drone companies, primarily in service-oriented companies. And that's a huge amount of money to see a return on. So what do you think is the next thing? What happened with robotics? It's now past the hype cycle. So where do you see drones applications going?
Well, first, where we stand today, because you asked me to look into the future. So I want to start with a short story that I've been told by a Boeing test pilot. That was already a few years ago. And he told me, you know, today at Boeing we built airliners with 2 seats in the cockpit. One is for the pilot, and the second is for the dog. Why? And he said the pilot's job is to feed the dog, and the dog job is to bite the pilot if he touches any switches. So really, and think about it, today, in order to take off from here, Tel Aviv, and land in Berlin or in JFK, you don't really need a pilot. It's a very easy mission, very easy task today to take off the plane at a certain altitude, certain elevation, certain route. He knows the destination, it's not a problem. So why today, isn't it done? You know why? Psychology. I guess that none of you would like or would agree to be on board of a Boeing when the pilot is on the ground. And this is the reason. So this is where we stand today. Today you don't need pilots really, not in military maybe a little bit, for sure not for airliners. But I believe that the drone today is a commodity. You go to the store, pay from $10 up to $10,000 and you get a drone. This is a commodity. And the future will be in doing the mission, the application actually of the drone. What should it do? What work should be done? And the level of autonomy that it will be able to implement this job. So this is one. The second is, yes, in hardware, and this is energy. You know that today, energy, as I said before, for a drone is 10 minutes, 20 minutes, that's it. So somehow it has to be solved. We solved it using a cable, but you know, this is not the best way. There might be much better ways to solve this issue, and this will be a major part of the drone industry in the next few years. And the next area that I want to talk about is a little bit about doing the mission not as one drone by itself, but as a swarm of many drones flying, sharing the information between themselves, and doing the mission as a swarm, not one by one. Again, sharing the information, sharing different parts of the mission, and doing it together as one entity. This is also another direction for the drones.
Okay, another interesting topic is human-robot interaction. So given that there is this proliferation of mechanical automation, physical automation around us, how do we interact with these automatons? And there's, today, we were seeing a proliferation in parallel of augmented reality and virtual reality and natural language processing and nonverbal communication with machines. So the question is, you know, given Alexa now, you can actually get Alexa to do stuff by talking to her. So that point has been proven. Where are we going in terms of controlling the robots? What kind of new applications or new kind of human-robot interactions can we expect in the near future? So let's see if we can hear first from David Hansen. Can you hear us, David? No? We don't hear you. Sorry. No. David, sorry, there's no sound.
Can you hear me now?
Yeah.
Oh, great. Okay. So, regarding human-robot interaction, we are moving towards more human-like interactions, and we are also moving towards multimodal interactions, which include touch screen and typing type interaction. However, as robots become more and more capable, we need to be able to communicate with them, have them communicate to us, and have them understand us in ways that are extremely intuitive. And that brings in the need for psychology, good psychological design of the robot and understanding of the meaning of communication. And psychology, of course, is not complete when it comes to these matters. What does it mean to make a facial expression? There is an old science called the facial action coding system, which has been shown to be very rudimentary, and most good animation arts don't obey that practice. And most people in face-to-face interactions are not completely adhering to the facial action coding system. So, the language of gestures, the language of facial expressions, which we've explored through our character arts and computer animation, can be an intuitive kind of interface. The future of robots isn't necessarily entirely realistic robots like our Sophia, but also would include very cartoon-like interfaces, kind of like the Anki Cosmo, which is rather like WALL-E from the Pixar movie. So more cartoon-like natural interfaces, converging with machine learning and statistical machine learning that can represent a lot of the conversation plus nonverbal. We've got a long way to go before people fully master the different modes of communication with robots. So I expect that it's going to be kind of like a rapid process of evolution, almost like a robot equivalent of the Cambrian explosion. A massive diversification of different kinds of interfaces.
Great, thank you. David.
So I think that one of the main challenges today when you design a robot is actually understand the way we interact with it. And I think that a robot or a utility robot initially is designed to remove frictions between us and a specific task we want to do. And in this case, the design actually needs to focus on how we make the things very simple, very intuitive, very effortless, and most of all, very natural. We don't want to feel like we are interacting with a machine, but we are interacting with a device that makes everything easier. I think that everything that happens with the voice user interface that came with the Alexa and the Google Home is a very good example of how we can interact with devices not only for ordering pizza or something, but to actually make them do stuff. And I think that we're going to see more and more utility robots and robotics in general, and maybe even drones that you can talk to and ask them to do specific things. Another thing that I think we're going to see quite soon is that the drones and the robots not only will be connected, but will actually be smart, and they will know how to anticipate things we do and help us, even if it's cleaning the house when we're getting out of the house without us needing to actually tell them to do so. And I also think that design will focus less on the looks of the robots and more on the way we interact with them, because again, that's the key for having a right experience, having an experience we want to have again and again.
You know, I'm not in the B2C business. I'm in the B2B or B2G government, where the life cycle cost of a product does not derive only from the price of purchasing it. You purchase it and then you operate it for many years usually, and most cases the most expensive part is the human resources. So you want to be able to minimize the team that should operate the mission. So the next challenge again will be the level of autonomous that you can give and allow your drone or your robot or your system or whatever it is, because when you can save per unit only, let's say, 2 people a year, in 3 years' time you would save the whole cost. So this is a challenge, again, not only to operate the vehicle itself or the drone, but also to perform the mission fully autonomously. And this is, again, a big challenge because there are so many degrees of autonomy and levels. You can start from something that can just fly, but this is level 1. And you can end with something that you don't need human at all for 1 year. And this would be like level, I would say, 95. And you know, look what happened to pilots. I used to be a pilot, and well, I'm still, but it started more than 100 years ago. The Wright brothers, Kitty Hawk, 1903, December 17. They flew for 12 seconds the first airplane. And today, 100 and something years later, we actually need pilots for aerobatics. Not much more than this. Well, I'm a little bit exaggerating, but this is the general idea. To take the man out of the loop and to keep the machines working by themselves.
Thank you. So an interesting point is the life cycle cost of this new automation. We are basically transitioning from a very niche, lucrative world of industrial automation. If you think of it, the car industry and the robotic arms have grown together. You wouldn't be able to produce 700,000, we talked about it, 700,000 Volkswagen Passats are produced every year. The bill of material of a Volkswagen Passat is estimated at around 12,000 euros. It's sold for around 40, 50,000. So the scaling there is another interesting challenge for robotics. So if so far robotics was designed for industrial applications where scaling was critical, where mean time between failures, where the automation was to last for 10 years. Right now it's going into a consumer world where it's more about appealing to mass consumers, to be able to also self-diagnosis of this very complicated machine. So the question is really now to the panel. So over the next few years, when we're going to see robotic arms and mobile vehicles being introduced into the consumer space, and the bill of material is going down and the needs are increasing, what kind of applications, or how do you see the world evolving, given that you're going to have robot arms and mobile robots, just like self-driving cars, but for other applications like security, like surveillance, like bringing the beer from the fridge. All of these new kind of mobile robots, and this is something that we're also doing with this new operating system. How do you see a world where you've got now a push towards a decrease in bill of material, and the life cycle cost is less of a problem in that world? So let's hear first of all, so from David Hansen, who's now I think going through this process from making one-off Sophias to mass production. How do you see this evolution of things in the life cycle of robotics?
Thank you. I see that the low-cost sensors that are available and low-cost computing, we can now put into robots. For example, you can see some of the components that we're putting into our Sophia head. They have cameras embedded in the eyes, which are low-cost and extremely high resolution thanks to mobile computing. We are using the mass manufacturing technologies that are used in consumer products to make low-cost components for these extremely high-end robots, and also to import this technology into mass-produced low-cost consumer robots. the design flexibility for being able to rapidly design and prototype robots has improved tremendously in the last 15 years. So we've gone from handmade robots. Literally, a lot of the mechanical designs originally were handmade from epoxy, carved material, from metal work that I did as a graduate student, just with my own two hands, to rapidly designed, scanned, printed, easily printed parts that we can print in our studio facility, or 3D printed metal parts that we can send out, and they come back within just a matter of days. So the design cycle for these robots is increasing. The ability to make many skins, so you can see we're mass producing Sophias on a product line. We've just got face after face of these robots. The robot technology. This is the Hubo body here from the Albert Hubo, walking Albert Einstein robot. This which won the Global Robotics Challenge. They have begun to mass produce these walking Hubo bodies. So we have the Sophia Hubo. So the kind of convergence of all these technologies allow us to make synthetic organisms very quickly for experimenting and what it means to create an artificial life form that also allows us to do application development really quickly. This means that we can cycle through business opportunities to explore the market applications. Now, from where I'm sitting, I'm interested in platform, because who knows what a social robot can be used for. We've proven that it can be useful in medical education, medical therapy. It can be useful for advertising, promotion, education. But what else, right? So these platforms, treating them as a platform, treating robots and developing robots as platforms allows you to explore applications until you find a killer app. So personal computers are an example of a general purpose platform. However, it was a few killer apps that really launched the entire industry. And the same thing winds up being true for smartphones. They're a general purpose platform. A few very useful apps then open up the entire app store market. So looking at robots, instead of as special purpose devices, looking at them as an extension of all these other smart technologies and integrating them into cohesive packages, and then putting those out there to explore the varieties of applications can allow us to open up new markets very rapidly. So that's one of the reasons why I think that markets for robotics are expanding so quickly. Of course, the same thing is true for artificial intelligence, and the marriage of artificial intelligence and robotics is, a match made in science fiction heaven. Making machines really, really smart is going to add lots of value to the future of autonomous robots.
Okay, thank you. Okay, let's go for a more general kind of question, less technical. With regards to robots replacing people, we've seen all these studies about human labor being replaced by automation. So it's a process that has been going on for a couple of centuries, but it's now exponential. Pretty much anything that we do, including any kind of creativity, any kind of thinking, any kind of problem solving, dexterity, can and will be replaced by automation. So even things, like creativity and journalism have been replaced by automation, and now the physical labor is being replaced by automation. So the question is really, where is society heading with this kind of transition, and how are governments fit for this new world where productivity is done through automation? So you don't, if today we measure GDP, we measure metrics of success in productivity. So in a new world where all productivity is automated, how do you measure success? How do you ensure quality of life for the human race. So let's start with Gabby.
It's a tough question. As I said, the future will be, we are phasing out, as human beings, and we will keep for ourselves the part which is more enjoyable. But again, looking seriously into the future, I believe that the part that will be taken by robots and machines will be more of the functional part. Of course, obviously in manufacturing processes and etc., but also in functional parts at human beings' life. But I don't believe that in the next, I would say, even 50 years, a robot, any kind of robot, even this nice lady robot over there, will be able to somehow replace where you need some emotional part, when you need some personal touch, and all these stories about deep learning and AI. I understand it's there, it's here, but I don't believe that it will be able to replace the man-to-man interaction, or women-to-man, or man-to-woman, woman-to-woman. I hope I'm politically correct, and all other options. I don't believe that this will be replaced in the next 50 years.
First of all, I think it's a real philosophical question, but from my perspective, human beings are the best we do is adapt, and I think that during the last 100 years we've adapted to having electricity, or having cars, or having computers, or internet, and we still adapt to all of those things. And robotics and automation is one of those things that we'll just have to adapt to, as we adapted to phones and electricity and whatever, and vaccinations. So I think that we'll have to wait and see. I'm not sure about what you said, that robots cannot replace some kind of creativity and intimacy on conversation, because I think that today, as we can see from all that happens in social networks, some of this already is getting lost in a way. But it's definitely going to be very interesting to see, how it will end.
David Hansen, you live in Hong Kong, next to China, where the Chinese government has allocated allegedly $230 billion over the next. Yeah, well, China, done. No, it's over. Okay. So I'd like to. Do we have it now? So I'd like to thank very much our panelists, and thank you all for your time. And let's hope that things work out for all of us in the next 10 years. Thank you.
Thank you so much, and we really appreciate it.